get rid of meters, so you end up with your correction is actually milligal.
You don't plug out the survey distance?
No, you don't, because it's latitude correction. So you see how in your formula it's 0.817 times sine of phi. You don't have delta z in there. Does that make sense? Both, because this is not an elevation correction. This is just latitude. That's why at the beginning I started by saying we're going to be dealing with two types of correction, latitude on one side and elevation. Under elevation, we'll see Bouguer, free air, even terrain, even tidal and stuff like that.
So you said datum will be 139 centimeters.
Your starting point. That's what we chose. So that's the tricky part about it, because you could have taken a point because so what we want to do is, like I explained earlier, we want all of these different points to be above the datum. If not, you have to go back and think about, do I add or subtract at this point if it's below, if your elevation is below the datum. Questions? Any questions? Okay. So and then we end up plotting this using either MATLAB or Excel. On the x-axis, you'll have your site elevation. No, your meters to start, which is what I call the location. So you start at 0 up until back to 0. And then on the y-axis, you have your corrected value of r. That's the plot you get.
From the reading in Excel, can you see degrees here?
No, so you have been given just this,
Yeah. Oh.
just 42 degrees.
You're going south, so it should be like the 41.
You don't have to look at it, because so that's the tricky part here. When you look at it, you think you have to drag it all the way down, but it's not dependent of elevation. So you'll get the same value for latitude correction throughout.
But it's depending on the angle of the ground. If you go south, like 30 degrees,
Yes, but we're not doing this here. We're just doing distance south. We're doing distance south. Does that make sense?
I guess you just do it.
Yes. Does that answer the question? No? Yeah, so we're not looking at it. The angle remains constant. Because if not, you would have needed to be applying a different correction at every elevation. You can end up doing it if you want and see what your result would look
Yeah,
like.
you just start smaller.
But see how there's not much, and every time you do it, I don't think it's even going to be an elevation difference of 10 meters at the end. So you could attempt and do it and see what the results would look like. Good? Alright. So for problem 2b, what you do is I'm talking about Excel, but you can do that using MATLAB. You want to add a linear trend line to your plot and display it. So at the end of the day, after you on Excel, in Excel you go, you add trend line. You have an option of formatting your trend line. So you ask it to display your equation. It's going to give you y, some value of m, and then some value of b. M is the slope and b is the y-intercept. So this is a formula you guys need that I don't think was given to you in class in order to solve that second part, that part B of problem 2. You get your value of the corrected G from the previous figure. Now you subtract your slope M times the station location, and then you subtract your the y-intercept. So you could just add an extra column that says residual milligal to do just like we did here. Instead of this, we'll end up with residual milligal, and then you plot it again versus your site location. Okay? So you need that formula here. so you guys can